So, as far as connecting one LCD is concerned, so there are some pin structure for the LCDs, and these pin structures are more or less standard one, like these are the commonly available pins on some LCD panel. Okay. So, pin number 1 to 16. So, that is pin number 1 is the VSS, that is connected to the ground line. Then pin 2 is the VCC, which is a positive supply voltage, which is 5 volt. Then pin number 3 is for contrast adjustment. So, you can put some voltage value there, accordingly the contrast of the display will be selected. Then the pin number 4 is for register selection. So, as I said that there are different types of registers inside the LED inside the LCD panel. So, it is basically if you have got if you are there is a control register and there is a data register. In the control register we put the commands for the display, and in the data register we put the display the characters or the graphics or whatever it is, whatever pattern we want to display. So, they are put onto the this data register. Then there is a read write pin. So, which is read or write. So, whether we are trying to write something onto the panel or we are trying to read something from the panel, like sometimes we need to know the status of the panel. So, what it is doing and all that. So, then we can have this status input through the by activating the read line, and if you are trying to put something onto the panel, so you can activate the write line, and that way you can put that write control to the LCD. Then there is an enable pin. So, this enable pin, so naturally for the operation of the LCD, this enable pin should be activated. Then we have got this data lines DB0 through DB7. So, they are for this giving the data and control to the panel. And then there is some LEDs LCD displays, they have got this backlight facility. So, you can put this backlight by this differential input LED plus and LED minus. So, you can control this backlight part. Some LCDs may not have this backlight and some LCD may have this backlight. Out of them, this register select, so this is very important. So, this pin, so if RS equal to 0, register select is equal to 0, then the instruction command code register gets selected. So, whatever you are writing, so that will go to the command port, that will go as command to the LCD panel. So, it will be stored in the command code register, and if RS equal to 1, then the data that you are showing, that you are sending, so it will be put onto the data register for display. Then the enable, so enable LCD to latch data presented to data pin. So, this enable is naturally this is similar to all other enables. So, you just enable it, so that it will be the value that you are putting onto the data bus will be put into the data register for display. And there is a read write pin. So, it is 1 for reading and 0 for writing. So, if you are trying to write something onto the command code register or data register, you should put a 0 here, and if you are trying to read the status of the LCD, so you give a 1 there on the read write pin. So, there is a standard set of commands that are understood by all the LCD displays. So, these are all standardized, like the command 0F, the function is to turn on LCD, turn on cursor, and the cursor blinks. Okay. So, these three things are turned on by giving a command. So, on the command port register, so if you write 0F, then this will happen, LCD will turn on, cursor will be on, it will show the position where the next character will be input, and the blinking will turn on. Then if sometimes we want to clear the screen, so that for that you send a command 01 to the LCD display. So, this command goes to command port command code register, and the display gets cleared. Then return home. So, return home for the LCD panel. So, you can have a home position defined. So, maybe if it is an LCD panel is like this. So, normally there may be 2 lines on the LCD panel. So, this may be the home position. So, cursor was somewhere here, say. Now, if you say return home by 02, so the cursor will come back to this point, and depending upon the setting, so it will start blinking or something like that. So, then increment return home, then decrement cursor. So, decrement cursor will take the cursor back by 1 position. So, if cursor was here, so it will be coming back to this to the previous position. So, that is the decrement cursor. Similarly, increment cursor will take the cursor to the next position. So, you can so if you are putting some pattern, so you can use this increment cursor, decrement cursor commands for putting the cursor at a proper place, and then you put the data to be displayed. So, that the data that the pattern that you want to display will become visible. Then we have got this 0E for display on and cursor blinking off. Sometimes we do not want the cursor to blink, so it should remain as a steady output. So, the cursor does not blink. So, that way display is on, turned on, and cursor blinking is turned off. Then 80, it will force cursor to the beginning of first line. So, it is a 2-line display, as I was telling that most of the LCDs they have 2-line displays. So, if you give the command 80, it will take the cursor to the beginning of first line. Similarly, if you put the command C0, it will put the cursor to the beginning of second line. Then 38, so 38 it will stand for use 2 lines and 5x7 matrix. Okay, so 5x7 matrix means how many dots will be there per character. So, that is a 5x7 matrix. So, so many dots are there. So, based on these dots, so you can select some pattern to be displayed. Then we can have say 83. So, it is cursor line 1 position 3. So, this is an example. So, there are a number of positions. So, that way you can put it at you can put the cursor at a particular position. So, 80 will take it to the first position, and then 83 will take it to the third position, like that. Then 3C will activate second line. So, second line will become active, and 08, if you put 08, then display will be off, cursor will also be off. C1, so it jumps to the second line position 1. So, C0 is the second line position 0, C1 is the second line position 1. Then 0C, so display on, cursor off. C1 jump to second line position 1, C2 jump to second line position 2. So, this way, so 8 will identify first line, C identifies the second line, and then for a position within the line, so you can go to the second part will be specifying that, like C1 takes it to position 1, C0 takes it to position 0, C2 takes it to position 2, all in the second line. So, this way you can control the cursor and then put a character to be displayed, so that it will be displayed at the current cursor position. So, how to operate? The first thing that we should do for an LCD operation is to initialize the LCD. So, we send the command 38 hex to the 8-bit data line for initialization. So, LCD is connected to the data bus of the processor. So, sending 38 hex to the 8-bit data line, so it will initialize the LCD. Then we want to turn the LCD on, the cursor on, and also the cursor blinking on. So, for that the command word is 0fx, as we have seen. So, 0fx will be put onto the command port. So, it will be displaying the LCD will be on, cursor will be on, and the cursor will also blink. Then we want to go to the next position of the cursor. So, we can send 06 hex for implementing it, and then we send a 01 hex clearing the display and return the cursor. So, that way whatever if something is there on the display, so it will go off by putting 01 hex by so that way we can do it. After that, we should make this read write low and make rs equal to 0 if data byte is sent is a command, and rs equal to 1 if data byte is if you are sending a data byte. So, if you are sending a command byte, then rs equal to 0. If you are sending a data byte, then the data will be displayed. So, this read write equal to low. So, so after that, so the data is written. So, read write equal to low means this write is activated. So, the data byte will be written either to the command port or to the command register or to the data register. After that, we place the data byte on the data register, okay, and pulse give a pulse on the E line, the enable line, from high to low. So, this E line makes a transition from high to low. As a result, this the display will be enabled and the pattern that I have sent will be displayed. So, then we are repeating this process for sending another data. So, this process should go on for sending different characters to be displayed. So, we advance the cursor position and send the next data byte to be displayed. So, that way it will continue. So, after sending each data byte, so you can write, you can give a write control to the LED to the LCD display, and it will be outputted onto the corresponding register. So, this is the interfacing diagram. So, we have got this particular diagram is for this display 162A, JHD 162A. So, it is a 16 by 2 LCD module. So, each line has got 16 cursor positions, and there are 2 such LCD lines. Okay. So, there is a 2 line display, and if you look into the connection pattern, then you see that we have connected this port 1 to the data lines of the LCD DB0 to DB7, they are connected to port 1.0 to 1.7. Then this line, this register select, then this read write and enable. So, they are controlled by pins 13, 14 and 15, and rest of the pins are connected to VCC, VSS, and then this 5 volt power supply is connected here. So, this way we are, so then this V is for contrast adjustment. So, there is a pot here. So, if you change this pot position, then this V will change. As a result, the contrast of the display will change. Some of the displays may have this. Then this LED plus, LED minus. So, LED plus has been given 5 volt, LED minus has been given 0 volt. As a result, this backlight will be turned on. Okay. So, we can do this thing. Then on the 8051 side, so there is nothing new here. So, the port 3 bits 3, 4 and 5 controlling these 3 bits, and this port 1 controlling the data bus line for the LCD. Then the program for doing it is move a comma has 38 hex. So, that we will be using 2 lines. So, we are willing to use 2 lines and 5 cross 7 matrix structure. Then a call command. So, this command, so this will call the routine for putting this output onto the command port. So, we will see how this is done. So, this is that command. So, what it is doing? So, in the A register we have got the 38 hex. So, that is moved to P1. Then clear P3.5, clear P3.4. So, we just need to see what are these 3.5, 3.4 etc. So, this 3.5 is RS. So, our 3.5 is the RS register, RS bit. Then 3.4 is the read write, 3.4 is the read write, and 3.3 is the enable. Okay. So, these 3 are the setting. Now, we can look into that command code. So, the command code you see, first we have done clear P3.5. So, this register select register select bit is cleared, and then this, so we are writing onto the command port. Since this bit is cleared, means we are writing onto the command port. Then this clear 3.4. So, this will be clearing this read write line. So, we are trying to write some value, and set bit P3.3 and clear P3.3. So, we are giving it a pulse of high to low, okay, on the E line. So, as a result, the value will be put onto the register, and we put a small delay routine, okay, for the value to get latched, and then it is returning. And this delay routine here is very simple. So, it is just clearing the 2 bits. So, we need a very small amount of delay for latching the value. So, we do some useful thing, clearing P3.3 and clearing P3.4. You can, for that matter, you can put any other statements here which does not have effect on the operation of the LCD panel. Okay. So, you can do that. So, if we go back to the program. So, what we are doing is that we are simply putting the 38 hex onto the command port, command code register, then 0fx. So, 0fx, it will turn on the LCD, cursor will be set on, and blinking will be turned on. Then the again the command port, it will be written. Then we are putting 01 hex onto the command port. So, screen is cleared. Then we increment the cursor so that it comes to a valid position, and then cursor line 1 position 2. So, we move the cursor to line 1 position 2 by doing this, and then we activate the second line. So, 3C hex, so that this will also activate the second line. Then this 49D, so this is some value that we want to display. So, A called display. So, display routine, so it will put this character 49D. So, 49D is basically so this is decimal 49. So, this will be put onto the whatever be the corresponding character. So, that will be put onto the display. Then we are then after that we are putting the character 54 decimal onto this A register, calling the display routine. So, this 49, 54, 88. So, these are various the ASCII code for different characters that we want to display for some pattern. So, this 32 is the space. So, that way it is just outputting some pattern onto the display. Then this one 70, so that way we are 76, 67, 68. So, they are outputting the corresponding pattern onto the display. Then we jump to the second line. So, this ends the display of the first line. Then we come to the second line. In the second line, for going to second line, we have to output something to the command port. So, zeros, so that basically is C1 hex. So, that should be outputted onto the command port. So, that is done here, command register. Then this 67D, so this is the first character that we want to display. So, that is put here and call the display routine. So, it will be displayed. Then 73 decimal, so that is the next character that we want to display. So, that will be shown here, and that will be displayed, that will be put into the display register, and that will be shown there. So, this way all the characters that we want to display on the second line, so they are put one after the other, and this the display routine is called, so that it will be putting that value onto the display register. And at the end, so we are just after all the characters that we want to display has been shown, so we are putting the program into an infinite loop here. So, unlike LED programs where you need to again start displaying the first character, because by this time the content is lost, but here it does not happen because there are dedicated registers to hold the values. So, once you are putting different characters at different positions and then calling for the display routine, so that display part remains there. So, it is not vanished, okay. And the refreshing circuitry is built in with the LCD panel. So, the refreshing circuitry will ensure that at periodic intervals, so it will put the corresponding characters that you have put at different cells and refresh them. And if you want to clear a cell, then for that purpose, so you have to write a new character onto that cell, or if you want to clear the display altogether, so you can do that by that clear display type of command. Okay. So, this program is infinite loop here, because nothing more serious needs to be done. So, this was the program for this command code part. So, command code register is loaded with this value, this statements. The command code register will be getting the values. Then we have got the display routine. So, this A called display we have seen. So, here also the same thing. First we move this A value to P1. So, we do set B P3.5. So, P3.5 was that read write line. So, we are putting so 3.5 line is set. So, that I am this is that this is that RS bit register, RS bit line. So, RS bit line is set to 1, meaning that whatever we are writing will go to the data register. Then clear P3.4 and set B P3.3. So, these are fine. Then clear, so say clear P3.4 will be putting that read write by line to write, making it a 0, and there is a pulse on line 3.3. So, that will give a pulse from high to low. As a result, the selection will be enabled. Then this A called delay. So, this will put a delay here. So, after setting all these things, the value that is available on the P1 register, P1 port through the data bus, it will go to the data register of the display. Then A called delay, so it will put a delay, and then you are returning going to the program point at which it was called. So, in this way you can interface a number of LCD, a number of interfacing devices to the system. starting with say simple keyboard or simple single LEDs to multiple LEDs to 7 segment displays. Then we have seen the connection of 8255 as a programmable device, by which again you can connect a number of other interfacing devices. Then we have seen this other interfacing devices like this ADC, as analog to digital converters, where you can connect some and you can get some analog signal converted into digital value and stored inside the microcontroller or microprocessor. Or the digital to analog converter, where you convert this digital value to corresponding analog value, and when you are going to connect some actuator to some microcontroller or microprocessor, so you can put the digital value there, it will be converted into the corresponding analog signal, and then it is outputted to the actuator, so that in the environment that actuator gets the control and it behaves properly. And finally, we have seen another display, this LCD panel displays, and these are also quite common in many of the displays that we have. So, of course, there are more advanced versions of LCD, the color LCDs and all that. So, only thing that is going to differ is basically some more selection lines and some more comments. Okay. So, if you are looking into a particular display, so what you need to see is that what are the extra comments and what is the sequence in which they are to be activated. Otherwise, the interface remains same. Interface remains same with any microcontroller or microprocessor you are going to connect it. So, only the sequence of this command that you are sending and the data that you are putting, so that will be varying. So, this way we can connect a number of devices to the microprocessors and microcontrollers.